For the square root property, it's helpful to remember that square root is just the opposite of squaring. So the square root property says that if x squared equals p, then x equals the square root of p or the negative square root of p. So for example, if we had x squared equals 36, the opposite of squaring would be to take the square root. So we're going to take the square root of both sides, which on the left-hand side, the square root will cancel out the squared. And on the right-hand side, we have to remember that it's necessary to keep in mind the negative possibility of the square root of 36. So we have x equals positive and negative 6. If you plug back in a positive 6 into the x squared plus 36, you'll have 6 squared, which definitely equals 36. And if you also plug in a negative 6, you'll have negative 6 squared, which also equals 36. Now, using the square root property in solving quadratic equations is exactly the same method. We're going to isolate the expression that contains the squared term, use the square root method, remembering the plus minus symbol, and of course, isolate the variables when necessary, and of course, check. So, given 3x squared equals 150, we first have to isolate the x squared. So we're going to divide both sides by 3. Then we have x squared equals 50. The opposite of squaring is to take the square root. So we're going to take the square root of both sides. While 50 is not a perfect square, there is a perfect square hiding inside the factors of 50. 50 is the same thing as 25 times 2, and 25 is a perfect square. So we can pull out 5, because the square root of 25 is 5. And we now have a solution for x. X equals positive and negative 5 times the square root of 2. Always check your solutions by plugging them back into the original problem, making sure that the left-hand side equals the right to ensure that you have factored correctly. Next, we can try something like 2x plus 3 squared plus 10. We already have the squared term we already have the squared term isolated, so we're going to take the square root of both sides, remembering that plus minus symbol on the right-hand side. On the left, the square root cancels the squared. And now we have to isolate the x on the left-hand side. Subtract the 3 on both sides, and then divide by 2. Always be sure that there's no perfect square hiding underneath the square root symbol. In this case, there is not a perfect square hiding in there, so we're good to leave this as is. Our solutions are x equals negative square root of 10 minus 3 over 2, and x equals negative square root of 10 minus 3 divided by 2. Plug both back into the original problem to make sure the left side equals the right side. And in both cases it does. So we have used the square root property correctly.